It's the challenge for users is kind of figuring out what search terms to use or what to use. And like for me, I call it calculator content, where like you just take content that's already written and then you modify it slightly to make it kind of how you want it. Like you add a calculator to it, right?
Alrighty. Well, hey, thanks so much for tuning in, everyone checking out the video here. But look, I am stoked, super excited, and just flattered to be having an opportunity to chat with these two fine folks. I have with me Michael Cohen, the creator of Velociraptor, which
John.
is phenomenal. And hey, super glad to have you here. And alongside of Matt Green, over both these folks at Rapid7 doing digital forensics, incident response. But we got an opportunity to just get together, and I thought that would be phenomenal to, I don't know, hear from the source all the incredible stuff that Velociraptor can do and all the great things that we can do for analysis and investigations and all this world. But hey, I could sing your praises forever, guys. I didn't know if you wanted more of an intro there yourself, or we can do some live demos and have a ton of fun.
No, that sounds good. That's great. I think we should just have some fun.
I'll let you screen share or dive in, whatever we're up for.
Yeah. Let me screen share real quick.
Perfect.
Yeah. Okay. So I just prepared a small exercise to show you how Velociraptor can be used in a typical incident. It's a little bit contrived, but I'm trying to hit a lot of the type of the capabilities that we've got, pretty quickly. So I have a Velociraptor instance here at demo.velociraptor.rocks, and I have a bunch of clients connected and so on. What I'm going to do is I have this one particular client here. I'm just going to show you some of the capabilities that we have around looking through the virtual file system, looking through the file system on that endpoint. So we have the VFS feature here, and that is kind of like similar to a Windows Explorer type thing, where we can simply just go in there and if we hit this, we'll refresh and just kind of like view the files and browse through it. And so if you are connected to this endpoint, let's say using Windows Explorer, then you'll be able to maybe go through and click through and open each one. But this is just an interactive way to do it. And I can also recursively refresh the directory. So just read all the files recursively through. And if I was looking at, let's say, a browser history type investigation where I needed to see whether a browser went to a malware site or whatever, then I'd have to click through administrator, app data, local, and then there's a couple of browsers here. There's a Google, maybe Chrome, user data, and then there'll be like a default, and then I'll have to manually recognize those interesting files that are interesting for the typical investigation. For instance, the Fev icons, I might right click, download from client, and then just fetch that history, that kind of thing. And then you can see that it's got this little floppy disk icon, which tells me that we've fetched that file, and and we can look at the file in the browser and have a quick look through it. We can also download it and look at it properly. But that's kind of like like sniper forensics. You go in there and you kind of interactively get the files that are of interest. But it's actually quite inefficient, and it kind of, as you can see, I've been clicking around. It's kind of useful for just grabbing like one file or a few files that are particularly of interest. But to do like at scale forensic, we really need automation, and that's what Velociraptor is all about. It's really about automating this forensic process and making it really fast, really efficient. So in the example that I'm just going through here, just looking through, I manually try to fetch the browser sensitive files, but instead I have something called Artifacts. And Artifact is sort of like a VQL program, Velociraptor query language program. So it automates a lot of the manual stuff. So in this case, what I wanted to do is I just want to get browser artifacts. And as you know, browser artifacts there's a lot of SQL files, in browser artifacts. So I have an artifact here called SQL Hunter, which is a super automated artifact. Just goes out and fetches all the SQL files that it knows about from a ton of different browsers and parses them. So all I need to do is just, and it knows where they should be and that kind of thing. So I'm just going to select the artifact and call launch. and immediately it goes out to the endpoint and looks for SQLite files, right? So it does what I was doing there with the VFS, manually. It does that automatically super quickly. So right away, I can see it's brought 21 rows. So it found 21 SQLite files. And I can also get it to upload the actual files. But if we look at the results, then these are all the different SQLite files that it found, from various browsers, the Edge, Chrome, etc. And over here, it actually goes ahead and starts to parse those on the endpoint. So I don't have to, take those files and ship them off the system and work out, how to parse them, that kind of thing. So, so I straight away can go and have a look. There's some YouTube stuff, and this is the, and then over here I can see the different browsers. That's Brave, and then there might be other browsers, Edge, that kind of thing. So basically it is super automated, and it also does Windows activity cache and other things that are also SQLite files. So it doesn't just do browsers. But this is an example of how VQL can really super automate all of these things. So let's think about another use case that we can use for automating things. So let's suppose that we want to know whether this machine had been compromised, right? So there is a very useful tool called Hayabusa, which is a automated way of matching Sigma rules against the event logs on the system. So whereas normally Sigma rules are matched against Elastic backend, Elastic, or some kind of SOC type thing. With this tool, Hayabusa, it runs them locally on the endpoint. So Velociraptor can take care of the problem of delivering the tool to the endpoint and running it. So all I have to do is just select that, and there's some VQL there, but we don't really care about it too much. And we just go ahead and run this Hayabusa thing. It's going to take a while, and it has a ton of different rules, and it will match whatever is on there. So I'm gonna let that run for a sec, and we can see it downloading it and running the command on the endpoint. So we might fast forward this part of the video.
Oh, no worries. Yep.
Because it takes a couple of seconds. Yeah, it will take probably about a minute or so.
Okay, cool. No worries. How are you holding up, Matt? I'm sorry. I didn't know. Keeping you quiet too long. I don't know if you're muted here. I'm sorry.
You're muted, yeah.
I haven't seen this, so for me, it's good to see other workflows.
Cool.
Yeah, not an expert workflow, but I'm trying to hit a lot of the big artifacts that people use, and a lot of people are really like fond of Hayabusa. Eric Capuano, and Recon, they use that a lot. It takes a long time. It's quite a heavy tool. That's why it's taking a while, because it's running a lot of rules, and it has a lot of false positives as well. And a lot of the rules are pretty weak, so it ends up just having a lot of false positives. So I guess if you have a customized rule set, it will be okay. But to
give you an idea how we use it internally in the IR team is we actually do a collection of the raw artifacts, and then we run this tool offline. So that's the thing to keep in mind with Velociraptor. Like, there's many ways to skin that same cat.
Yeah. It's going to take a couple more minutes. Come on. How long does it normally take? It takes about 3 or 4 minutes, I think, normally. No, I did have. Come on, you've got to be there.
No rush. No worries.
However long it takes. I guess we can always fast forward that part, and it will be magical.
May I ask, how does Hayabusa compared to Chainsaw? That's always one that I hear as another knee-jerk reaction to, hey, cutting up event logs and trying to match them to Sigma rules.
Yeah, I mean, they're both very noisy, right? I think that's the problem with Sigma rules. Sigma rules tend to be very noisy and quite weak, because a lot of them rely on names, like, oh, this file executed from that file, and so they tend to be a little bit weak and they're quite noisy. So unless you are, so at the end, it's the same thing, right? They're just matching Sigma rules against so it's the same, right? Mm-hmm. But it's about the rule selection.
How we use these tools is we use TimeSketch. So
yeah.
what we found is like Sigma processing in TimeSketch was hard. So we use this tool, and it like pretty much just lists out the events that we want to bubble to the top, and then throw it in TimeSketch, box time. And it's a super cool way to deal with all that noise that is usually outside the time frame that you're interested in.
And I'm sure TimeSketch keeps that super clean and at least a little bit more easily, I don't know, searchable, queryable. Like you can click around. There we go.
Yeah, exactly.
All right, so it's done. All right, so a little while later, we will see that Hayabusa has completed, and it found 3,000, Sigma rule matches. So there could be quite a lot. And we can look at the results that it found, and you can see that it has a bunch of different rules here for different Sigma rules, and they will match different things. But you can see that there are, 3,000 rows. It's very hard to manually inspect these things. So we need some way of, let me just get rid of this cell. We need some way of post-processing that a little bit to get a little bit more information from that. So we have this thing in Velociraptor called a notebook. And if you have ever used Google Docs or, or similar interactive type document that you can use for interacting with, collaborating with other people, then, notebooks should be very familiar. It's basically a way that we can run arbitrary Velociraptor query language, VQL, on the results and do post-processing. So in this case, I'm reading all the results from the Hayabusa thing. But what I want to do is I want to actually group by the rule title. And that will basically fold out all the different hits into just distinct hits. And I can also add a count to count how many there are. And I'll remove the limit. So now it will basically tell me all the unique rules that are hit. So I'll just get a quick overview of the type of Sigma rules that are hitting on this. There are still quite a lot. There's 81, as you can see. And some of them are, clearly false positives, admin logon, so what, right? But as I go through and quickly review it, because now it's a lot less than what it was before, like 3,000 before down to 80, then I can see the different types of suspicious things, and some of them are looking quite worrying. So for instance, we have a who am I utility execution. That's very weird. I always look look twice at something like that. And we can see that it's running from PowerShell. Who am I running from PowerShell? We got next.exe. These are the typical types of utilities that are used during initial recon on the machine, when an attacker lands on it. So this is always something interesting to look at. And so immediately Hayabusa is flagging certain types of behaviors. So that's interesting. Let's see what else we can do with this machine. So there's lots of interesting things going on. Let's collect the process tree and the process listing. So I'm going to collect the following artifact: PsTree. And if you've ever used volatility or something, you would know PsTree is just ordering the processes in a tree. And PsList is just flat out listing the processes. And this time I'm actually going to configure those artifact collections a little bit. And we can click the configure parameters so that we can change some of the parameters with these artifacts. Artifacts take parameters and we can tweak them. In this case, what I'm going to do is include the PsTree and launch it, and then just collect it. So what's going to happen now is it's going to go out to the endpoint and fetch the process tree, and immediately I can see the results. We have the process listing and the process tree. Now in the process tree, I can see all the different processes and their call chain. In other words, where they started from, where they were called from, all the way up to the top of the call chain. And that's a really strong indicator to tell me, how did this process get there? Where did it come from? And so you can see the thing that was concerning me is who am I? So I'm going to search for any cold chain that contains who am I? And that will, let's go over here. Any cold chain that contains who am I? We can do it in VQL, where cold chain. Let's call exe. That is who am I? Oh, that didn't come. Sorry.
No worries.
We might have to do that again. I mean, we can see the PSExec here, right? Let's search for services. Yeah. It might have been, I might have done it too long ago and it's come out of the cache, I think.
I see a PowerShell just about there. Yeah. I don't know if
yeah,
that's
so there is a PowerShell there, but so I think I did it about an hour ago, and so it took it probably came out of the cache because it's only caching it in for a short time. Let me what I'll do is I'll just delete that again, and let me jump over to my thing. I'll do the thing again, and then it would work because it would go back into the cache.
You can always try EVTX Hunter and show the sysmon logs.
Yeah, let me just stick to the script that I've got, because otherwise it's going to be interesting. Because so that's basically what happened, right? The Hayabusa has told us, looking at the sysmon log, of these things that happened. But what I wanted to show you now was the process tracker that keeps things in cache for a short time so it can enrich the data. And I guess that has expired from the cache, so we are not seeing it there, but it's obviously still in the event logs, right? So that's why it's not showing right now. But let me just do that recon steps again, and then it would, show that. So sorry about that. We'll
no worries.
Rewind and try it again. As I said, some of these artifacts are going to be, hit and miss, in real life, because it depends on, what's happening, right? Especially process type data is volatile, and, and these kind of things. So let's try again. Okay, so Hayabusa has indicated that there's some suspicious processes going on. So what I'm going to do is I'm going to try and collect the PsTree, which is a way of visualizing the processes with a parent-child relationship on the system. In this case, what I'm going to do is configure the parameters, and that allows me to change the way the artifact works and to tweak that a little bit. In this case, what I'm going to do is ask it to return the full process listing, the full process tree for each artifact. So I'm going to launch that, and Velociraptor is going to go off and fetch the process tree, and you can see that it lists every process, and then it lists the call chain. The call chain is the context around where the processes have come from, who launched which process, and so on. And so I know that Hayabusa has indicated a suspicious process, for instance, was who am I? So I'm going to look in the call chain for a who am I to see whether, that is, that Velociraptor knows about it. So immediately I can see that there is a process called who am I, and Velociraptor knows about it. And it's been spawned from processes PSExec, right? So which is a pretty typical lateral movement method. So what's actually happening is, it's really interesting, is that when the user is logging, when the attacker has logged on using PSExec, they start to do recon activities and launching different processes and so on. Normally, if we just do a PsList, we can only see the processes that are currently running. But Velociraptor has something called a process tracker. In other words, it keeps track of processes to a certain time after they've exited, so it can enrich information about recent history in the last, let's say, half an hour or so of processes. So it knows when a process is exited. So this is really interesting. When the user has run whoami, the whoami process launched and then exited. So if we just did a straight out PsList, we would never see the whoami process because it's already finished, right?
Yeah.
And that is indicated here by the fact that the end time is set. So Velociraptor knows about the process and it's ended 2 minutes ago or 3 minutes ago, whatever. So let's go back to this and visualize this again. What I'm going to do now is, because I know that it's launched from services.exe, that's the call chain for my suspicious process, I want to know a little bit more context around what happened around that. So I'm going to go back to one of the main parents for it, and I'm going to look at the process tree coming from there. So I see the services.exe and then all of its children, which it's going to have SVC host and other things. But this is the one that I'm really interested in, is that it has the PSExec service. And that is a typical way that PSExec works, is it launches a service from services.exe. And then PowerShell is the child of that. But the interesting thing about this process tree is that now I can see all of the attacker activities as the attacker went on, and even processes that have exited, because the tracker keeps track of them for a certain time. And you can see that these processes have exited because they've got an end time. So the attacker basically went through the ran whoami, the ran some net user command, they ran some ping, they ran the system info command, and then finally they ran beats admin to download a malicious malware. This is pretty typical type of progression. So they grabbed the malware, and now we know how they went through using this method, right? So we don't really need to. So now we want to look further and see, what's interesting. So we know they've used PSExec, and this is really interesting because there is this very little known fact that since PSExec version 230, PSExec actually works a little bit different. So due to reasons that are described here, it actually creates a file with a particular name when it's being used. So that's really interesting. And Matt has pointed out to me that the other day, so he uses that a lot, because it's an interesting artifact that we can look for. So I wanted to show how we can look for file creation type artifacts that can be used to detect PSExec specifically. So what I'm going to do is I'm going to use the USN journal. Now, as you know, the USN is a journal in a file system that keeps track of file system activity. And in this case, what we want to do is we want to find any kind of evidence of this particular file name to be created. And it sort of looks like PS key dash, and then there's the host name, and then it's a dot key, at the end, right? So what I can do is, so this artifact basically parses the entire USN on the endpoint and returns, the data. So what we can do is we can actually just filter. We only really want to know about a file that ends with, dot key, right? And then see any kind of files that happens, on the endpoint. So we are filtering on the endpoint, being kind of more targeted. And that will give us an indication of when the PSExec connection happened. So we have like a timestamp, so we know like when the key file was created and that kind of thing. So that's going to take a few seconds, but it shouldn't take too long. Yep, there it is. So it's returned 20 rows, and if we look at the results, then there's a couple of false positives here, but then we can see these kind of file creations. And here we can see the reason for the file system activity. We have file creation, and the key file is created, and PSExec creates that key and then deletes it. But at least we know now a timestamp exactly of each time PSExec connected to the system, and there could be a number of different connections 8 hours ago and so on. I think, yeah. So that's a way of using NTFS forensics to help us to establish detection.
And
Okay.
this is really useful because like that host name that's in that file name is actually the source machine. So if you've got situations where maybe logging is messed up by the customer, you can actually get the source machine from this file.
Yeah, that's the machine.
That is what PSExec onto this target?
Exactly.
That's wild. I had no idea.
But it has to be a newer version of PSExec. The old versions don't do this.
That's a little gift that sysinternals gave us, right?
Wow. That's okay. This is phenomenal.
Yeah. Okay. So that's pretty cool. So the other interesting thing is that we saw is PowerShell. We know that the attacker used some PowerShell and these kind of things. So I'm just going to show you some interesting PowerShell type artifacts. What did the attacker do with PowerShell? So there's a bunch of different PowerShell things, and they'll look at different aspects of PowerShell. So for instance, this one looks at modules. This one at PS readline and so on. And we basically look at various persistence strategies for PowerShell and registry and all this. But anyway, we can just click all of these ones and just go ahead and collect them all. And it's going to go off and fetch whatever it can from these artifacts. And it's kind of interesting because this PS readline, for instance, is a nice one because we can see every time that there is an interactive PowerShell, then it goes into the console history file. So that parses that out, and so we can see a little bit of the attacker activity from there. And so on. So that's a nice one. And then there's some module analysis case. So there's for persistence with PowerShell and all this sort of stuff. So PowerShell is something I would look at next. And then the other interesting thing that we saw as part of the process tracking is we remember that we have that bits transfer that happened. And bits is a really common way for attackers to move malware onto the system from a different URL, because they can, bits is a signed binary, and it's usually used for transferring updates. So let's look at the bits jobs that are created on these endpoints. And again, we have a artifact that searches for bits jobs that are created. It searches the event logs for it and tries to extract the URLs of where the jobs came from. And so we can see, there's a whole bunch of, edge updates and things like that. Those are pretty normal stuff. But then down at the very end, we can see some more suspicious stuff, that someone's downloaded an executable to the endpoint and so on, right? I mean, this is not malware, but it can be, right? It's just unusual, right? So we can see that immediately that there is some bits activity going on here, which is kind of unusual. So that's cool. So now we know what's going on, in this machine. So now I suspect this machine is compromised, but that doesn't really help me because I want to know, usually when attackers compromise one machine, especially with PSExec, they might compromise any number of other machines on the endpoint, on the network. And I want to know quickly which of these other machines are compromised. So I want to be able to hunt for the compromise across the entire deployment. So as you can see, we have quite a lot of clients here. And so we want to actually, now that we found the evidence of the compromise, we want to discover it across all of the endpoints. So what we could do is we can create a hunt. I'm going to create a hunt looking for services. Because as we mentioned before, PSExec, creates a service, right? So maybe PSExec was used elsewhere in the network, I don't know. And I can restrict the hunt by labels and stuff like that, but I'm not going to bother with that too much now. I'm going to just collect all the information about Windows services. So this artifact just lists all the services on the machine. And I'm just going to launch it. Sorry, here. And it starts at the post state. I'm going to hit start. Off it goes, and it immediately schedules it on all the machines. They come back. They might take a little while. So we've scheduled it. I think there's 105. One of them's finished, and it should come in shortly. With they should all come in. And as they come in, you can see that more and more finished clients are coming in. Now here we have a notebook. It's the same thing, but this is the notebook for the hunt. We can use that to post-process the results from the hunt. Now, in this case, what I'm interested in, so I can immediately say, if I suspect that the service is going to be PSExec, so I can immediately search for a particular name, PSExec, so I can be very targeted. But let's say that I don't really know what the service is that I'm interested, that is suspicious. So I want to do some stacking. I want to do some kind of analysis to say, what's normal and what's abnormal, right? So what I'm going to do instead is just look at all the services, and I'm going to group them by the path name, right? So the different services that came from different paths, right? Path name. And just like I did before, I'm going to count for each unique path, right? So now what this will do is we'll actually look across all the machines, all the services on all the machines. And hopefully, if some machines have an unusual, let me just hide some of these columns because it's kind of wide. So I'm just going to just hide them a little bit. Display name. I want to see the count. I want to see the path name. Yeah. Okay. So just a little bit easier. So if I filter this, then I'll be able to see the most common services, right? So that's not that interesting because it's going to be everywhere. But if I look at the least common services, then straight away I can see this very unique process PsExec has been installed on one machine only in the entire fleet. Now, of course, in real life, there might be a few machines and some admins might use them, but at least I'll be able to see that this particular service is quite unusual and has been installed on only one machine. So, so now I can just, filter by it, where path name matches this one, right? And remove the count. And that should just give me that one service that is, that one machine that's had that service installed on it. And again, it's our compromised, machine. Here's the host name and so on. So that's a way of doing this kind of hunting and detecting which machines have been affected across the network. And so that's an example of just a quick incident. It's a little bit contrived. It's very low hanging fruit because it's PsExec. But it sort of hit on a lot of the artifacts that we use to hunt in practice, and and scale up, and you do that scale to a large number of machines. And then Matt has actually got another use case, which is also pretty cool. So I'll just hand it over to Matt. I'll stop my share.
Well, hey, I don't want you to sell yourself short there, Mike. I think that was incredible. Like that really shows the easy button or multiple and many easy buttons for all the great stuff that Velociraptor can do. And like, man, you cruise through what was either 100 or like 200 clients in 2 minutes for, hey, try to do that mass hunt. Like
it's not a lot. So we normally we will normally have upwards of 10,000 to 50,000 to maybe 100,000 endpoints per larger deployment. So that is not a huge deal, right?
And that's incredible.
And just to add, Mike showed a simple use case there, but like attackers use that all the time, right? Adequate.
Yeah, the whole point is to automate the simple things, so we don't have to spend much time on it, and then we have more time to focus on the more interesting and complex attacks.
Yeah.